And next we're going to be talking about positive predictive value and negative predictive value. First of all, the equation. So positive predictive value is true positive over true positive plus false positive, while negative predictive value is true negative over true negative plus false negative. Now, what do these represent? So positive predictive value means from everybody that tested positive, how many are truly positive? And negative predictive value is from everybody that tested negative, how many are truly negative. So that is what these tests represent. Previously, we talked about sensitivity and specificity. Now, sensitivity and specificity are fixed and they do not change when there is a change in prevalence. Positive predictive value and negative predictive value, on the other hand, actually change when there's actually changes in prevalence of the disease. Now, first of all, what is incidence and prevalence? So, incidence is the number of new cases over number of people at risk. So, pretty much just saying in a certain given time period, how many new cases of the disease are there? Prevalence, on the other hand, is the number of existing cases over number of people at risk. Prevalence is the total amount of diseases. Prevalence is actually equal to existing plus new cases. Now, we said that positive predictive value and negative predictive value change based on prevalence. We're going to just see this by numerical values. So let's just take some theoretical values. Let's say that we have a test with a true positive of 15 and a false positive of 5 and a false negative of 5 and a true negative of 5. If we take these values and we just put them into the equation, then the following numbers is what we get. So for positive predictive value, it will be 15 divided by 15 plus 5, meaning that the positive predictive value is equal to 0.75. Now, if we take negative predictive value, and that is 5 divided by 5 plus 5, then the negative predictive value will be 0.5. So if there is an increase in prevalence, that means there's an increase in the total population of disease. So there'll be an increase within here, within true positives and false negatives, since there'll be increase in disease. So let's just take this and increase this by 20%. So if we increase this by 20%, that'll be 18 over here and will be 6 over here. Let's do the calculations with a new increase in prevalence. So if there's an increase in prevalence, then the new values will be, positive predictive value will be 18 divided by 18 plus 5, giving the new positive predictive value of 0.78. And the negative predictive value will be 5 divided by 5 plus 6. So the new negative predictive value will be 0.45. This shows that as there is an increase in disease prevalence, there is increase in true positive and there is an increase in false negative. This demonstrates as there is an increase in disease prevalence, the positive predictive value will increase, but the negative predictive value will decrease. Alright, so like we said, that prevalence will change positive predictive value and negative predictive value. So there'll be an increase in positive predictive value and a decrease in negative predictive value, but there is no change on sensitivity and specificity. So if you look at this, now if you look at sensitivity, if you remember that was true positive over true positive plus false negative, so that means that would be 15 divided by 20, which gives us 0.75. And even with a 20% increase in disease prevalence, it will be 18 divided by 24, which is still equal to 0.75. So sensitivity will not change. And if you look at specificity, it will still be, if you remember the equation is true negative over true negative plus false positive. So that'll be 5 divided by 10, which is 0.50. And even with the increase in disease prevalence, there's no change. This is why when there is an increase in disease prevalence, there's an increase in positive predictive value and a decrease in negative predictive value. Another thing that you need to know is that when there is a decrease in disease prevalence, there will be a decrease in true positive, a decrease in false negative, and this will lead to a decrease in positive predictive value and an increase in negative predictive value. So overall, when there's a change in prevalence, there will be a change in positive predictive value and negative predictive value, but sensitivity and specificity will remain the same.